Hi, everyone. This is Bobby Harris from the Utility Broadband Alliance. It's my pleasure to welcome you to today's uh, webinar. Um, we're just holding a second to let everyone get logged in, and looks like that's happening. All right. So again, I'm Bobby Harris with the Utility Broadband Alliance, and it is my pleasure to welcome you today to this important webinar. I'm going to quickly turn it over to Jacob Reeb from Cambridge Consultants because we want to get straight to the heart of this, and Jacob will be the one leading us through. So Jacob, take it away, sir.
Thank you, Bobby, and I definitely appreciate UBBA giving us a chance to have this webinar for its members and others that have been able to join us today. As stated, my name is Jacob Reeb, VP of WDS within Cambridge Consultants. We're excited to have everybody on the webinar today, and really our subject is around transforming utility networks to the modern world. Joining me today will be Gavin Doyle, who is part of our tech strat team, part of our advisory services, but are wrapped around technology and technology development. And he's going to share some of the findings we have within Cambridge Consultants of the baseline of what's going on in the utility space, and as well as some of the areas of innovation and challenges that are happening in the space. Joining us as well would be Brian Lee and Ron Brady, both from utilities within the United States, giving their unique perspectives of what they see in the space and where they're at as far as those organizations. And we picked two that are definitely in two different places within the utilities and as well as building out their communication networks. Really, the topics today are around, what's driving the commercial space, what's happening within the innovations, and how you can potentially do all this, and the latest technologies in wireless technology. Before we begin, I want to touch really quick because I think a lot of people on this phone call do not know who Cambridge Consultants is. And if you do, you're kind of wondering, what are we doing in the utility space? Ultimately, Cambridge Consultants builds world-first technologies, IP, and as well as a defendable position for our clients. And our clients tend to be companies that are trying to either disrupt the space or potentially an organization that is trying to move into a new area and disrupting it with new type of technology. And that's what we're about. We're doing this for 60 plus years, giving defendable positions to our clients with multiple engineers, 800 plus that have multiple disciplines from some of the world's greatest universities in the world. 500 projects per year, et cetera, et cetera. But again, what are we doing in the utility space? Well, the reason we're here today is that we've learned a lot from the utilities, which Gavin's going to showcase today, but as well as we see an opportunity to start to drive innovation in that space in a market that, to be honest, has been stagnant or has been struggling with an adoption rate. With that all said, within telecommunications and technology, which I head up for North America, we have three visionary areas. Network transformation, which was really wrapped around, brand new type of technology. You could probably throw 5G in there and et cetera. Accelerating digital transformation, which we'll come back to, which is really what we're communicating and talking about today, and as well as building intelligent networks. Again, this whole space is under digital transformation. What we're seeing here is the evolution of moving from public networks to these private networks. And more importantly, what's driving the innovation ultimately is the ability to build what we consider custom or bespoke networks that are wrapped around the application itself. In the utilities, it's not any different, or utility space, it's not any different than any other segment that we ran into in the challenges they have. It starts with the communication, but it quickly molds into areas of these end nodes that have direct impact to the communication network that is honestly different than what you see today on most MNO networks in the space. And underneath all these challenges, you can see all the different aspects and workloads and things that are happening on the network that will cause these challenges. For us, what we see is the opportunity to build the specific network to the application and make it efficient and as well evolve with that specific application. Building things around AI, doing network splicing, being able to do open source things like ORAN, and it goes on and on and on. Again, in the prior slide, we talked about why we're here. Ultimately, what we're doing this webinars today is that over and over again, I've heard the adoption rate is slow. The reason I feel the adoption rate slow is ultimately there's a lack of the feedback loop. We don't get an opportunity to talk to the utility. And to be honest, a lot of the suppliers out there don't quite understand the unique application needs of what's happening in the utility space. So with that, I will turn it over to Gavin Doyle, who will go through the challenging electric grid and the things that we've learned. And then from there, we'll move into the Q&A session with the team from Excel and Southern Link.
Thanks, Jacob. My name's Gavin Doyle. I'm a senior consultant in Cambridge Consultants Technology Strategy team here in Cambridge in the UK. And I'm focusing on wireless and digital services in the energy sector generally. And I'm going to try and give a summary here of the changing nature of the electrical grid and the significance of wireless communications to this change. So this should be relevant to many types of utility companies. But first, I'm still going to try and give an example of and explain how the electricity grids are evolving to illustrate the bigger trends taking place. So apologise if I'm telling you a bit that you already may know about the changing electricity grid situation. Next slide, please. So I think most people on this call will probably recognise or understand what I'm showing here, but for the benefit of those that might not, the electricity system needs to be balanced to exactly meet demand and generation on an ongoing second-by-second basis. And the traditional grid, as shown in the middle here, did this in a centrally controlled way. However, the grid, as we know it now on the right-hand side, is becoming much more decentralized, with significant and growing generation and storage located in the distribution areas. And this means that the traditional approach of central control of electricity grids is becoming more challenging. Next slide, please. The challenges can be categorized as we've shown here. So on the left-hand side, we've got new energy assets, and the chart here is showing the new energy generation capacity added in Texas and the growing amount of renewable energy sources within this mix. In the center here, we have grid capacity. So electricity consumption is due to grow through the mass adoption of EVs, and also due to the electrification in many other areas, including heating and industry. And there's a lot of investment required in the grid infrastructure to cope with that capacity. And on the right, we had grid balancing. So this extra demand and the larger renewable energy in the mix is making the grid much harder to balance, and hence the cost of balancing is increasing. Next slide, please. So we've got a changing electrical grid, and the key question is, how do we deal with these challenges? And a potential answer is, a smarter, more automated grid is needed to keep the operating costs low and to keep the lights on, ultimately. Next slide, please. So how does wireless communications fit into all of this? Well, wireless communication enables many applications in smart grids, such as, working from left to right here. We have grid automation. So, for example, substation transformers need to be monitored to potentially detect reverse power flows for safety reasons. Just one example. And much of this infrastructure has got the power, obviously, but no existing communications infrastructure, so there's no fiber optics or fixed comms, and therefore wireless has a part to play there. For distributed generation, storage, and load control, again, all of these devices, these distributed resources, require reliable connectivity to a wide range of different assets, which don't necessarily have the comms infrastructure with the required service levels that might be needed for this kind of critical grid service. And then we have mission critical communications. So field operatives need to be able to communicate reliably and securely wherever they're located, often with advanced functionality. Well, I say advanced, but functionality such as push to talk and group call functionality. And then we have augmented reality or augmented virtuality. So in this example, maybe field operatives could use augmented reality glasses to overlay identification and safety information onto their real world view. Next slide, please. And across all of this, security is absolutely paramount in this future grid. Ultimately, more connected devices will massively increase the electrical grid's attack service. This is a simple fact of a smart grid. In many cases, the key standard for smart grid communication would be something like IEC 61850. And it doesn't necessarily, these protocols and standards don't necessarily have the security capabilities needed to accommodate this connectivity in a smart grid. And for this reason, there's lots of different frameworks, which we're showing on the right-hand side here, which govern the implementation, the operation of IT and OT networks in order to mitigate that risk. Very simply, this all needs to be taken into consideration in wireless service selection or wireless service design. Next slide, please. So what are the latest innovations in wireless technology that are relevant to the electrical grid? Next slide, please. Well, the use of wireless networks in grid edge applications is a lot less developed than wired communications, certainly. And there's some key technology innovations that will promote wireless use in this area. And they're categorized as shown here into cellular comms, non-cellular connectivity, network virtualization, and edge computing. And I'll go into a bit more detail on these aspects in the next slides. So next slide, please. So for cellular communications, 4G connectivity is ubiquitous, but it doesn't provide the service levels required for this future electricity grid. 5G can meet some more demanding service requirements, but in most cases, this requires investment in order to bring that to reality. The diagram I'm showing here shows the 5G triangle. So for those of you not familiar with this, the key aspects of the key service aspects of 5G are EMBB in the top right, which is enhanced mobile broadband, high-speed smartphone connectivity. Ultimately, bottom right we have MMTC, massive machine type communications. Ultimately, for very large numbers of IoT devices. So I would consider NB-IoT and LTE-M. Even though that's hinting at 4G technology, I'd consider them to be part of the 5G stack because the standards for those are being taken forward, whereas a lot of the LTE standards aren't. On the bottom left-hand side, we've got URLLC, ultra reliable low latency communication. So this is wireless comms for automation and control of industrial type critical systems. And then there's some additional capabilities with 5G at the top right, which are things like functional improvements such as network slicing and advanced beamforming. But the key question in all of this is what kind of cellular network will provide the coverage and the SLAs you need for your requirements? So is a public network suitable, or is a private implementation more appropriate? And the key questions to ask, the follow-on questions are: how secure does the network need to be? Do your devices need to be able to seamlessly roam onto and off the public network? What is the impact of using licensed or unlicensed spectrum? Can a simpler technology give a better ROI? Is the technology commercially ready? And is it available? What level of customization is needed? And have you got the expertise to implement this ultimately, if you were doing it as a private cellular build? Or these are the key questions around cellular comms. Next slide, please. For non-cellular connectivity, there's a growing number of alternatives to cellular. I've got some images here showing things like the Helium low R1 network coverage in the US. The bottom left is showing the European Sigfox network. Sigfox is a low power wide area network technology, same as low R1, but it's more popular in Europe. It's ultimately a French technology, and that's why I'm showing a European view of this. And in the bottom right, we have satellite IoT connectivity, and here we're showing the EchoStar 21 low R1 connectivity over Europe. There are satellite IoT connectivity services across the US as well. They're just a bit harder to show in an image because we're looking at swarms and constellations of satellites that are much harder to show nicely in a diagram. Next slide, please. Network function virtualization and slicing is really important. So NFV, I'll shorten it to. It enables network functions to be virtualized and delivered using off-the-shelf hardware, and network slicing enables this network to be split into dedicated sub-networks with the functionality and the service level that they provide aligned to specific services in the end. Now, we think there's an opportunity to be early to market here with an edge virtualized sliced cellular network. But there are significant technical challenges that exist with this, including what off-the-shelf hardware is going to do that job. Do you actually need some bespoke hardware as well to supplement that? How do you do dynamic switching between these hardware slices depending on the requirements of the services at any given time? Particularly for compute heavy functions, what kind of hardware is going to do that job, and also orchestrating all the bandwidth and the availability of these services again in real time. These are some really big challenges, and the image here that we've got on the right hand side shows this arrangement whereby the key cellular network devices, which in this case I'm showing 5G, a 5G implementation. So the 5G DU distribution unit is shown as part of the edge device, so there could be some edge compute running that. And we've got maybe some of the core 5G services running in a hybrid cloud or in the cloud, and then a radio unit providing the wireless connectivity with different slices, in this case for different types of IEC 61850 messages, or for augmented reality or virtual reality comms for smart field workers. And in all of this, if open standards can be used and open APIs can be used, then this comm system can be more easily linked to business systems, so enterprise resource planning systems and things like that, or operational systems, so automation and control systems as well, can be linked into the comm systems to make a more holistic system overall. Next slide, please. And connectivity is only one part of enabling the smart grid. Ultimately, the smart grid is a digital transformation project. So what we're showing here is Cambridge Consultants' digital transformation reference architecture. And we can see with the large circles at the top that if you take compute and storage resources, they might be located at the edge for more critical functions, or further towards the cloud for management and analytics functions. And you can see the compute and the latency resources change depending where you locate that compute and storage. But if you have that capability, that compute and storage resources, and you combine that with things like connectivity, so 5G, time-sensitive networking, open architectures, cybersecurity goes across all of this, then all of a sudden this architecture enables a smart infrastructure, so in this case a smart grid. And if you have a smart grid, the benefit of that is further opportunities, so you can update the products and services that smart infrastructure is providing, using data, using usage data and value-adding analysis. You can enhance the system, so bring in new products and services based on, again, data-driven insights from this architecture, or you can evolve it to, open as yet unknown opportunities. So, an out there suggestion would be that this kind of architecture could ultimately lead to the autonomous operation of the grid to a certain degree, and also bringing in huge numbers of participants into the grid and allowing the grid to allow those participants to operate the grid in a very autonomous way. Next slide, please. So in summary, the grid needs to be engineered into a smarter system, and wireless is a key enabler in all of this. Smart grids have got some extreme communication requirements, and that needs to be configured and provisioned dynamically normally. And the connectivity infrastructure needs to be delivered efficiently, ideally within a single platform as possible, ideally sweating existing assets where possible. And I'll just add as well that there are some new networking technologies as well, such as intent-based networking, as an example, which may be critical for the advanced configuration and management of these kind of communication systems in the future as well. So I think you've heard enough from me. I'll leave it there, and I'll hand back over to the rest of the team. Thank you.
So thank you, Gavin. With that, we're going to move on to the Q&A session. And if Ron, if you would kindly join us here from Xcel Energy. Hey, Ron, how are you?
Doing well, Jacob. How are you?
Perfect, perfect. So I think a really good place for us to start in this Q&A session is a quick introduction of yourself, and as well as an introduction of Xcel Energy, not so much as a utility, but where you're at currently with your network infrastructure, communications, and in this case, we're really talking about private cellular networks. So you can give us kind of the groundwork of where you're at today. I think that'd be really helpful for everybody on the call.
Sure. My name is Ron Brady. I'm a senior network architect for Xcel Energy and LTE subject matter expert. When we talk about Xcel and where they are in their quest for private LTE, I mean, we're like a lot of you out there that are on this webinar. We're trying to make the best decision for Xcel Energy and our customers that we can with regard to smart grid and telecommunications. We started our network out on commercial cellular, and due to growth and expansion, we quickly realized that this was going to be unsustainable for the long term. So even though commercial cellular did meet our immediate needs and allowed us to launch a lot of our smart grid initiatives, we quickly found out that our commercial carrier partners were either unable or unwilling to support our service level agreements, coverage requirements, and even capacity requirements in some cases. Not to mention, there was a big lag in the features they were willing to support, even though 3GPP and private LTE or commercial LTE could support it. There were some things like priority calling that they just were not willing to support for us. So that had set us on the course for looking into private LTE, and of course all of the challenges that comes with that with regard to spectrum, technology, feature sets, customer needs, business use cases, and then of course cost and cost management.
All right, that's great. So kind of going to moving on here. As you see this evolve, and especially for an organization like yourself who's just starting to take this on, what requirements are unique for you guys? And again, we've talked over and over again about the legacy equipments out there, and as well as what's kind of happening in the 21st century of distributed energy, environmental concerns, and specifically, we just got done talking a little bit about the impact of potential things like EV and wind and solar. So what are unique applications that are really putting an impact on your network, and where do you see the evolution kind of moving and the opportunity for people in this space?
So yeah, as we start to investigate private LTE and how we would deploy that, the first challenge was spectrum. Given that and investigating that, taking a look at all the options that are out there and trying to come up with the right choice for us, that was one of the first challenges, which we think we have our arms around, but we're still investigating. The other thing was modeling. Commercial carriers, their uplink, downlink modeling is the exact opposite of what we need it to be as a utility carrier. They tend to be more downlink centric. Well, in our case, we're more uplink centric. We're sending that data to our control centers and operation centers, and usually the downlink is not all that heavy. It should probably, for efficiency's sake, we found that at least a 50-50 versus a 30-70 split would probably accommodate us more, which commercial carriers are never going to change that. Their bread and butter, are the folks that are downloading or streaming videos on Netflix. But we found that was a challenge. The other challenge that we had was we have some cases, like in the cases of solar farms and wind farms, where we actually are going to need to island coverage. We may not need contiguous coverage, but we need the ability to island that so that we can provide that high capacity primary or backup coverage in these facilities wirelessly, so that we don't have to worry about fiber cuts or actually losses from network connectivity through traditional means. Other things that we were looking at too on the strategic side, there's no way that we could deploy edge AI type computing without being able to be in control of our own destiny, being able to control security, making sure that that our network meets those NIST SIP requirements and the security protocols that are necessary to keep the state safe, to keep our customers safe, is paramount to us. So, and then when you start talking about other initiatives that are strategic, truck of the future, drone control, EV management, that is something that we're just now starting to scratch the surface of. How are we going to do that? And the only realistic way would be to do it wirelessly without a significant investment in infrastructure. Even though private LTE is a significant investment, it's definitely more cost effective than trying to build hardline infrastructure into every house and visibility into every location where we might have EV chargers and so forth.
Yeah. So the next question, which I think a lot of people are kind of looking towards, right? And I expect when we go to the Q&A session, it would potentially come up, but it's, as you look at your legacy equipment, as you look at the adoption rate for wireless as you go through this, what will evolve here? And again, the question will come up, why not 5G, right? Why not move to 5G? And I think we need to kind of encompass that with what you currently have out there in the legacy equipment, the impact it has on an LTE or a private cellular network, and what will need to transpire for you to move to potentially 5G, or what exactly is going on there. So that'd be great if you can kind of tackle that, as I call it, the big gorilla in the room, because everybody's wondering about it, right?
Right. So actually, you hit on both ends of that evolutionary spectrum. First off, we need to have, from our partners, our vendor partners, we need to have them understand that we have to integrate some of this legacy equipment in there. We're not going to just say, oh, yeah, we're going to go to private LTE and that's going to solve all the problems, and we're going to cut all these other devices off. That's not going to happen. That's unrealistic to think that. We need a clear path for integration for legacy equipment, and that kind of brings you to the question of, well, do we go 4G or 5G? Chances are 4G is going to meet all of our needs at this moment in time, pretty much everything that we need. We may not even need to go to 5G. However, we don't want to be in a situation where we were with 3G, where 4G gets cut off and we have no clear path to 5G. There are spectrum concerns, there are equipment concerns, software. All of those things have to play into a partnership with the utility company. We have to have a clear path to integrate legacy equipment in at a 4G or greater level. We also have to have a clear path to 5G, because we don't want to be stranded. We're talking about hundreds of millions of dollars in infrastructure assets that we just are unwilling to strand. And what we need from our partners are clear path to 5G, and truly show us that this is long-term evolution and not just a one and done. So those are all the hard questions that we're asking and addressing right now, making sure that we don't find ourselves in that place where we have stranded assets, or where we're having to struggle to maintain legacy assets in the future.
All right, that's perfect, Ron. And I know we'll have a chance here to further our conversation as we go through the panel when we have everybody back together as we go through that. So with that, if you wouldn't mind jumping off, then we could bring Brian in and go from there.
Here we go.
Hey, Brian, how are you?
I am doing well. Thanks for having me.
Fantastic. So again, we'll start with the first question here. And what's really unique about this situation of having both you and Ron on this call is that, one, we had someone from Xcel Energy who's starting this path right down of building a communication network for their assets. You at Southern Link, right? You're well beyond that, right? You're probably first to market and et cetera. So I think it'd be really good for the audience to kind of hear who you are, right? Your role, but as well as where you're at today and what you're kind of thinking of as it relates to the ability to build wireless technologies on an existing network within Southern Link.
Yeah, sure. My name's Brian Lee. I work in our product engineering team, and I have responsibility for data products and services. And when you hear that, think about modules, think about fixed devices, think about routers, and so forth. And with that, also manage our certification of all those devices as well. As you probably know, Southern Link, we kind of operated a wireless, or have been operating wireless since around the early 90s. We had a IDEN network at the time. So if you're familiar with the old Nextel network, we were the other IDEN network in the United States. And, we focused on mission critical applications as well, such as push to talk, group call. We also had a data services, but obviously as the data requirements begin to strengthen over time, and also the fact that IDEN was into life, we began to look into new technologies that we could gravitate toward. In 2012, we began looking at different technologies, sent out RFPs, and then we landed on the LTE technology, quite frankly, because of its scalability and ecosystem. We have a 3 megahertz network that we focus on. I call it the 5 pillars of Southern Link, is reliability, resiliency, prioritizations, coverage, and security. And so when we were looking at LTE, we realized that we'll be able to obviously be able to meet those 5 pillars, if you will, and then be able to focus on our mission critical applications. When we first began, we looked at, again, push to talk being a main driver, but we are also looking at other mission critical applications such as AMI backhaul, transmission distribution SCADA, line devices, line switches, and so forth. But as we begin to deploy the network, obviously more and more use cases became available, and we've been deploying, devices supporting those use cases. Some of which, such as volt var management, where we've got line fault indicators, we have environmental monitoring, obviously C&I metering. We're now pursuing residential, where we're actually looking at embedding devices inside of the meter. So obviously, as you begin to deploy LTE network, the use cases become more prolific, if you will.
Yeah, and I think that's a perfect example of what we consider this application-based network, right? Your requirements are very unique. So as these devices start to go onto your network and as they start to evolve, what do you see the impact for your communication side? What exactly is going on there, and what are some of the challenges you currently have in this space?
Yeah, so obviously device ecosystem, I'm gonna say, is probably a challenge. Now, so we work real hard with various module and router manufacturers, many OEMs, if you will. I can name a few: Sierra Wireless, Telit, Sequans, U-Blox. On the module side. On the router side, we have everything from GE routers to Cradlepoint to Cisco to Sierra Wireless and so forth. Really, the device ecosystem is what we want to focus on, is making sure we can continue to evolve that, and also being able to work with our core vendor and RAN vendor, Ericsson. So obviously, I mean, we can talk about how evolution is. We're definitely keeping our eye on the 5G. Obviously, for us with 5G, it's going to take us to acquire additional spectrum. I think Ron mentioned that. So that's definitely a requirement we're going to need in the future if we go to 5G, or maybe the standards could change. We'll support a 3 meg network. So yeah, those are some of the I guess say requirements for evolution moving forward. And obviously with 5G, what we're interested in is going, or more important to us, is going to be latency. Obviously we don't offer millimeter wave or own millimeter wave, so latency is really going to be key for 5G. So then it can open up some other applications that we've been pursuing, such as PMUs and transfer trip.
Yeah. No, that's perfect. And we've talked a little bit about this and where you're starting to evolve as far as the wireless technology and, more importantly, your network itself. And this goes beyond potentially just the end nodes, but the network. And again, you just mentioned 5G, but I think it'd be really good for you to kind of talk a little bit about what you guys are investigating and how you're evolving your wireless network to meet these application needs and beyond.
Yeah, sure. So honestly, one of the things we're definitely seeing as an evolution in how we're evolving, we're starting to see more device integration. So we're starting to see more of the modules being integrated into line fault indicators, like I said, volt VAR monitoring systems, SCADA systems, whatever it might be. And one of the things that we're really seeing, we're in the process of deploying and actually have some pilots on the network today, is narrowband. I know a lot of people say narrowband is synonymous with 5G, but for us, we've deployed a narrowband channel where we're offering applications such as residential metering and also piloting network lighting controls. We're looking at possible transformer monitoring, and then obviously pole sensors and environmentals. So being able to monitor the pole, the sag, the tilt, and so forth.
Oh, that's fantastic. So we got a couple minutes here. I'll add one more for you as we kind of do this. What's been, we've talked a little bit about cybersecurity, so I'd like you to touch that a little bit, knowing you have an existing network and the challenges you potentially have with cybersecurity to a point, right? There's only the one thing about security is you can't share much of it because that violates the security you're doing. But how important is cybersecurity to you guys, and what are some of the challenges you have of being able to attack some of these applications out there knowing that?
Well, that's definitely one of our pillars, and security is the forefront of our network. Obviously, and as I know there are a lot of vendors that may be joining our call today. If anything, I would ask these vendors as they work with utilities to really focus on that. End-to-end encryption is going to be key. It's going to be one of the main requirements. I can't really go into Southern's which protocols, but just know that industry protocols that are being used today for end-to-end encryption is going to be paramount for our network.
All right, that's perfect. So with that, Brian, I definitely appreciate your time and being able to do a little bit of a Q&A, but if Ron would jump back in as well as Gavin, what we can do is open the floor for some of the Q&A from our audience if anybody has some questions. So with that, I think the one area I'd like to touch on that's been brought up, what are you guys seeing as it relates to AI and edge compute on either the existing network or potential new networks that you're deploying, Ron and Brian?
You want me to go first? You want to go, Brian?
Go ahead, Ron.
So when we start talking about edge computing, I mean, I see that we see that as more of a strategic play at this point in time. Now that may change tomorrow, but we definitely see that as a potential business case. We see the advantages of that. I can't go into specifics, but we have sat down and talked about how we would use that, how we would deploy that, what it would mean to our business units, and what it would mean to our customers. So I see that as very significant. I see us at least doing some pilots and deploying that and actually exploring those use cases to make sure that it's the best fit for Excel.
Yeah, from a Southern standpoint, I'll try to answer it this way. We are beginning to see some edge computing. For instance, one vendor of such we're working with embedding microprocessors and so forth inside of the device to be able to handle the processing there on the edge. So rather than sending it back over the network and then actually go into a control center, then you can actually do some of your switching, maybe some of your environmental, whatever you need right there on the edge. And another thing too, from a LTE standpoint, it preserves the integrity of your network too. So you just don't have various data going over your network. It's really going to allow probably you to open up and increase your, I would say, capacity, if you will, if you're concerned about that. So yeah, so we're beginning to pursue that with one of our vendors. There's other protocols out there or other ways that this will be able to support. Think about taking your different protocols you may have out at a substation and then rolling them into one. So we're looking at the open FMB, kind of being a way that we can leverage AI or grid edge to be able to support protocol conversion. So that will save time and so forth, not just for the network, but also being able to increase and boost your reliability.
That's great.
I think just, sorry,
go
Jake.
ahead. Go ahead.
I was just going to say, I think there's another aspect to this, which is device edge as well. The use case I'm thinking of here is for sensor fusion devices. So there's a lot of monitoring that's got to be done, often retrofitting sensors to devices. So you're looking at things like you don't necessarily have direct access to what's going on where you're monitoring. You're often doing sort of secondary monitoring, and therefore you've got to merge all of these different sensor feeds, turn them into events on the device, so that you're not sending lots of raw data and using a lot of resource to send that data. Turn them into actual events, and then the events can go to the cloud, or the cloud can come and see what events has happened, whichever way your security system wants it. But I think there's an important part to play, is having that might be AI, it might be some kind of neural network on a device to do that, because it's quite complicated.
Yeah, I agree with everything that's been stated so far. Again, one of the things we've realized at Cambridge is, you have one thing as far as the network's concerned, but being able to understand exactly the impact of anything that comes onto the network. And if you can offload that, it definitely helps as far as building an intelligent network to meet those application needs, because it can't be boundless of the amount of data that's coming across consistently. And if you can do things at the edge, it's fantastic. So we do have one question here, and then for everybody that's on the call, this definitely, please submit your questions. We'll do our best to answer them as they come across. So our first question, could you share your thoughts on the application of private BB at the substation level? What are the use cases for private LTE can enable at the substation level? So in other words, what's going on at the substation level? What's going on with private LTE, and et cetera? Does that make sense, Brian and Ron?
Yeah. I think, man, those use cases just keep growing day by day. It could be something as simple as a router connected to a SCADA controller, or something as complex as infrared video that actually lets you know that, hey, I've got a transformer overheating, or this gauge is in the red, or something like complex like pre-programmed drone control that actually does inspection of the substation, intruder detection. I mean, these use cases just keep growing day by day, and when you start putting those capabilities out to your employees, they're going to come back with all kinds of really great ideas to use things like video and data and monitoring and AI, edge computing. It's just endless. Even at the substation level, things that used to require a truck roll just for validation now is no longer necessary, because you can actually do all that over a private LTE network.
Yeah, Ron, you said a lot there, and I'd agree with every bit of it. I hate to say this, from a substation standpoint, maybe I take this for granted, but we're kind of doing that today. Some of the other use cases that we've used private LTE for is, monitoring the hydrogen within the transformers, the bushing monitors, and so forth. It's funny you mentioned the drone being able to fly along the substation and pick up hotspots. I mean, we're actually piloting that today with our aviation team, where we're using CBRS as backhaul. So yeah, I think there's quite a bit of uses for private LTE within the substations. I mean, not just I guess you say RTU, being able to monitoring line switching, being able to do your switching from a substation standpoint, but think about monitoring the doors into the substation. Okay, we're doing that today. Either with a keypad or what have you, where all the data comes back to ensure that person using their key card is that person. So yeah, there's just a plethora of use cases for private LTE within the substation.
That's fantastic. So we do have another question here. how will AMI 2.0 be different now that communication technologies have matured significantly in the last 10 plus years since the first wave of AMI?
Wow, that's a loaded question.
I'm glad they're not making it easy for us. That's fantastic.
Well, I mean, so essentially a lot of focus, I think, for us, what we're hearing, there's a lot of focus on how do we make that better? How do we make that more secure? For us, security has been this huge focus with regard to AMI, especially when you start talking about the use of bridges and mesh networks and potential for unfriendlies, man-in-the-middle attacks, and things like that. End-to-end encryption significantly will increase that AMI use and make it much more secure. A lot of leadership will be sleeping a lot better with that deployed, knowing that there's no potential for that type of attack. But as far as automated meters and stuff like that, we're seeing new technology come out where where even you could have CAD-M, you could have LTE under glass. So now all of a sudden the door is open to utilize LTE for much more than a middle mile play to support your mesh network. You can even breadcrumb your mesh network with the use of LTE or expand that with LTE where it makes a lot of sense. Again, things have to be addressed like capacity. Coverage is great, but without the capacity, it doesn't mean anything. So we still have a lot of work to do in that regard in terms of making sure that coverage and capacity is very balanced, making sure that security is there. But yeah, we could probably go on to the what ifs the improvements that have been made since those first forays into AMI were made. But for me and for my team here, the security is the most significant thing out there that since we started this.
Yeah, to piggyback on what Ron's saying, we had a conversation about this the other day. Like I said, we're starting to see the adoption of narrowband and CAD-M devices being integrated under the glass of a meter, both from a CNI standpoint and from an AMI standpoint. So, do I think the adoption rate will be, immediate? No, I think there's going to be kind of a play, or it's going to be where, let's say that those meters begin to fail, then you'll be able to pop in LTE. Now, there's also some benefits to LTE where a lot of the mesh networks didn't provide, and that's going to be from a broadband standpoint. So let's say if you have a power control meter, or let's say a meter where you want to do more and more frequent reads because your marketing really wants to be able to offer that. Okay, then the LTE will give you the ability, you'll have the ability with LTE to be able to service those higher bandwidth needs. It could be through CAD-M, it could be CAT1, you could use a CAT6 device. I don't know why, but you could. But my point is that I think it will be a complement initially, and then I think you'll probably see more of a transition into LTE as things begin to mature. And that kind of goes into, what's the future of this? It's definitely have to be that device convergence, and then obviously cost, right? So let's talk about that. That meter is going to have to be, I'd say, within sub $100, and so it's going to have to be able to meet those business cases that current AMI does.
Yeah. No, Brian, you hit on the subject I thought about right away, right? Moving from a security standpoint of either Zigbee or these LP WANs right into NB-IoT, which natively will have some or the ability to do further encryption as it goes across. And as well as when we start to get in AMI, I think from my standpoint, as you start to do this, these distributed energy centers, right? We brought up the EV market, right? And there's a lot that's going on here, from solar to wind to having, in essence, electric vehicle parked in your house, and how that all kind of comes together to understand the amount of capacity and demand that's coming on these networks. And I think that's a big thing where you're gonna have more and more communication that comes across. Gavin, do you have any?
Yeah. I do, yeah. I think behind the meter is really, really interesting, and like I said, there's lots of different resources behind the meter. Understanding the topology of the circuits behind the meter, what's there, how to connect to all of these different devices securely, with confidence that you know what that device is. And then if you're going to use those devices, so be that an EV or a heat pump or a battery storage system, if you're going to make those devices available to the network to offer products, to offer services to the grid, you've got to have confidence that they're going to be able to do what they say, that they've got to be able to convey what they're able to do, so that the grid has confidence that that battery is a battery and it does have this much charge in it and it can provide that charge at this time, and synchronize with all those other devices. So I think there's a whole world behind the meter of device discovery, securing devices, understanding what the devices are, and having confidence in their ability to deliver services. Really interesting area, I think.
Yeah, and I also say to you, you brought up, Brian, you brought up the marketing side of this. When you start doing AMI, right, the end users or basically the homeowners, the more information they potentially get, the more informed they are, right? And from an environmental standpoint, and Texas is deregulated, but that's the biggest thing, is what kind of offerings are you giving? How much information you'll be able to give them? And I think that's going to become more commonplace across the country as we start to do this, not the decentralization, but more about the information that's happening in the space. So we have about 8 minutes here, and I'm gonna give a loaded question, right? And the loaded question basically is, where do we see, the utilities or this industry as it relates to communication and the end nodes? You can take it to wherever you want to, but where do we see it moving in the next 5 to 10 years? What's going to happen? And more importantly, within that, how do we enable and speak to the suppliers to ensure the fact they understand where you want to go in the next 5 to 10 years and what happens? So if you guys want to take that question, that'd be great.
Well, I mean, I think probably in the next 5 years, as more utilities embrace LTE, you're going to see an opportunity for those utilities to come together. There'll be roaming opportunities. There will be mutual aid opportunities with less communications restrictions going on. Then you'll see them working together to produce applications and services. In the next 5 years, I think you could see quite a bit of growth in the utility sector and their ability to provide services not only to their customers, but maybe to work together to mutually provide services. I think when you open the door to a open architecture wireless platform, it is going to do for utility companies the same thing that Ethernet did years ago. It's all something we're using. We're now talking together. We're working together. Now it's more of a force. I think they will have a much stronger impact on the telecommunications industry as a whole, as an industry, versus what they have now, where they have to take what they get.
Yeah, I'd say, gosh, that is a loaded question. Since we've already, our first device we deployed was back in 2016, and so we've got some years under us where we've been now being able to offer LTE to more growing use cases. I think that's going to be what we're going to focus on, is definitely these use cases that are popping up. I mean, distributive energy is one of them. You mentioned the EVs. I think all those is what we got to keep our head on a swivel to be sure that we can be able to support that load. And so by doing so, how can we manage that better? I say, next 5 to 10 years from a utility, I think, like I said, you're going to see from an LTE standpoint, more device integration. You're going to see, rather than the routers, you can see companies, with line devices that's got the modules built inside. I mean, we're working with one company that's got an antenna, okay, that actually is embedding a narrowband module so it can monitor the environmental. So you'll be able to have more access to more information. The question is going to be, how can you use that data to better your company and to better yourself? So data analytics is going to be key as well.
Gavin?
I'll go for the network automation angle, I think. So I think that we may be looking at out beyond 5 years here, but I think that the automation of the configuration and management of these networks is going to become important. The configuration of and dynamically allocating these kind of resources, it may quite easily be beyond current sort of the way that these networks are currently controlled. So you're making use of things like the RAN intelligent controller to do that, and then automating that process to a degree is another aspect. But then how can you also understand what the state of the network is and understand the intent of the users of that network as well? If you bring all of these things together, so if you've got an understanding of the state of the network, if you've got an understanding of the intent of the users of the network, and all of those are feeding into and controlling the RIC with some kind of intelligence in there, then you're getting into a place that is, this is yeah, slightly utopian vision. I appreciate that, but you're getting into a position where you can step back and go off to the pub and leave the network to itself. Obviously, that's being incredibly utopian and very consultancy. I appreciate, but yeah, that's what I'm interested in understanding is how far, practically how far that can be taken, and what can actually, what aspects of that can add value to businesses. There's cost savings to be made there. There's service levels to be improved. These are the nuts and bolts benefits that might bring. So that's sort of what I'm interested in.
Yeah, and I'll piggyback on that. I mean, when we first started this and started working in the space of utilities, the first thing I heard is, they want to control their destiny. And Ron, you brought that up, right? I mean, every time you hear a new G, you just, it's like fingers on a chalkboard. It's very difficult because the utility itself has these legacy equipment, and they're used to putting stuff out that lasts 50, 60 years, right? And when you're evolving into all these different technologies, every 3 to 4 years, it's problematic. So the first thing is they want to own their destiny. In other words, you brought it up. Once we start to see everybody get the spectrum that they need and rolling out these networks, that's where I see things start to evolve. The second behind is they also want to own the data. You want to be able to own the data, and you brought that up, Brian, right? How do I take the data? How do I start to build intelligence? And Gavin, you hit on it. It is, for me, how do we build intelligence into these networks for either self-healing or otherwise, right? I always envision the idea of, knowing that you brought up fault line indicators, Brian, right? And this is a view, and it potentially could happen today, where you have a windy, arid day and you have an area that you have lines that have been known to go down, and you transform the network to communicate every 30 seconds to those fault line indicators or even more. So you know exactly when that line has gone down, it speaks up, and at that point, you're able to take the network and transform it to the fact that the critical aspect of that day was this part of the network. So that's just some of the ideas that we've been able to go through. So with that, guys, we're at 2:59 Central here, and one thing I want to do, right, can everybody see here? So I appreciate everybody taking the time to meet with us. I definitely appreciate Brian and Ron and Gavin have taken the time to go through their experience, and as well as the experience we have at Cambridge collecting information. So a real call to action here for all of us is, going back to, what are your innovation goals? What information do you want to share with us? We have a tremendous amount of thought leadership and case studies on our website that I welcome everybody to jump into, from things from, open source on things like ORAN to intent-based networks and building custom and complex networks. So if that's of high interest to you guys, as well as general questions you have about this webinar, I have my contact information up on the screen today. And with that, I will say thank you for attending our webinar. I hope you found this very informative, and take care and have a great day.
Thank you.
Thanks, Jacob.